Is Eureka Math, Module 5, Lesson 7, and we are going to continue using volume for rectangular prisms, but now we're going to do word problems, but don't worry, we're going to use only whole numbers, no fractions, so it shouldn't be too difficult, but you have to read carefully, okay? So let's go to our problem set, and you can go ahead and write your name on it. All right, Jeffrey, or Joffrey, depends on how you pronounce that name, but Jeffrey is the common pronunciation, builds rectangular planters. What are planters? They're boxes that people put plants in, okay? So there is a picture of a planter. And maybe I'll put a little plant in it. Okay, Miss Lure, move on. Jeffrey's first planter is 8 feet long and 2 feet wide. Okay, so there's his planter. And I'm even going to make it hollow so you can see. Oh, isn't that fancy? Okay, so it is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet. Okay, so here's the inside line, and that line goes to a height of 3 feet from here to here. Okay, or here to here, or here to here, 3 feet. What is the volume of soil in the planter? So not the volume of the whole planter, but just the volume of the soil, right? Explain your work using a diagram. Well, my diagram was a picture. So volume will be length, 8 feet, times width, 2 feet, times height, but not the height of the planter, just the height of the soil, which is 3 feet, okay? So 8 times 2 is 16, 16 times 3 is 48, 48 feet, what? Cubed. Do not forget the 3 on there, okay? So explain your work using a diagram. There's our diagram. I drew a nice little picture. I made it hollow. If making it hollow is difficult for you, you can just make it a regular cube. That's fine. It's not a cube. I'm sorry, it's a rectangle. Rectangular prism. Jeffrey wants to grow some tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet, okay? But he wants them all to be different. Show 4 different ways Joffrey can make these planters and draw diagrams of the planters' measurements on them. So we need to break that into height, width, and length. Let's see how we could do that. All right, well, we've got a 32 here. So what makes 32? 4 times 8, right? 4 times 8, and then we add the 0 on it, times 10. Would that give us 320? 4 times, oh, I'm sorry, that's a 10. 4 times 8 is 32, times 10 would equal 320. So, let's see. If I can make a box, that is 4 by 8 by 10. Okay, so this is where you're going to get some practice drawing in your, okay, so this would be the length would be 10, the width would be 8, and the height would be 4 feet. And if you want to show me that that's hollow, you just draw an extra line there, and an extra line here, and an extra line there. It shows it's empty, right? Okay, now we still have 320. Let's see how else we can break this apart. Well, let's see. We could, I like that 4 by 8, but that's not going to work for everything. So we could do 16 times 2 times 10. 16 times 2 equals 32. and 10 would equal 320, right? Okay, so this one's going to be super long. That's going to be 16. And then the width is going to be 10. And then it's not as tall as this one, it's just 2. So there we go. Okay. And those are feet, 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 feet. Okay, how else can we break that apart? Let's see. How about 4 times 4, which would be 16, times 20. 16 times 2 is 32, with a 0 on the end, 20. So 320 feet cubed. Okay, let's try that one. All right, so this one's going to be long. That's 20 feet. Oops, 20 feet. But it's not going to be too wide, just about like that. Okay. And that width is going to be 4, and the height is also going to be 4. Okay, cool. All right, let's see how else can we split this up. How about 5 times 4 times 16? Okay, 5 times 4 is 20. 20 times 16 is 320 feet cubed. So this one will be pretty long, but not as long as the other one. So 16. And then we'll make the width 5, like that. And the height will be 4. So there's the height. And don't forget to label your pictures. Good. Okay. Wants to grow tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet. So 320 cubic feet, 320 cubic feet, 320 cubic feet, 320 cubic feet. Show 4 different ways Jeffrey can make these planters and draw diagrams of the planters' measurements on them. So there we did it. Good. Okay, so it's basically you're just decomposing, splitting apart that 320 in any way you can to get 3 different numbers. So we did it in 1, 2, 3, 4 different ways, but there are more ways. Okay, number 3, Jeffrey, still Jeffrey, wants to make one planter that extends from the ground to just below his back window. Okay, well, I'm going to draw the side of a house, I think, here. And there's his back window, right? And he wants the window starts at 3 feet from the ground, so there's 3 feet from there to there. If he wants the planter to hold 36 cubic feet of soil, name one way he will build the planter so it is not taller than 3 feet. So he doesn't want it to go over 3 feet. So we can make it 2 feet tall. Okay, let's see. So if we want it to go right there, but we don't want it to go past the window, we could make it 2 feet tall. Okay. But how wide is it going to be? He wants it to be 36 feet cubed. So we're going to split that into 3 numbers. So I said 2 feet tall, right? And that would, see, that would leave us with, if we divided this by 2, 15, 16, 17, 18, that's 18. So we could go 3 and 6. 2 times 3 times 6, is that going to equal 36? 2 times 3 is 6. 6 times 6 is 36. There we go. So 6 feet wide. And, wait a minute. How am I doing this here? So that it, sometimes my pictures are a little bit wonky. Here we go. There we go. And this is going to be 3 feet. And then the height will be here. and that will be 2 feet. Now, will it go above the window? Nope, it shouldn't. It should fit right nicely under the window, right here, right there. Great. Explain how you know. Well, 2 feet times 3 feet times 6 feet equals 32 feet cubed, which is our volume. That's the volume he was looking for. And if the height is less than 2 feet, it won't pass the window. Good. Okay. After all of this gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. So he's keeping lots of materials in this shed, right? Do you know what a shed is? It's like a garage. It's like a storage, like a deposito. That's the word I was thinking of, deposito. Okay, so 6 feet long, 5 feet wide. Wait a minute. 6 feet long, 5 feet wide, and 8 feet tall. Now sheds usually have rounded roofs, but I'll give it a door, maybe a window. Okay, so there's my shed. And it is 8 feet high by 5 feet wide by 6 feet long. Okay, all right. He realizes he needs a shed with 480 cubic feet of storage. He wants 480 cubic feet. Well, how much does he have? Well, first we have to figure out what he has. So 8 times 6 times 5. Okay, so 5 times 6 is 30. Times 8 would be 240, right? Feet cubed. Will he achieve his goal if he doubles his dimensions? Why or why not? Well, he wants 480 and this is 240. Well, if he doubles the dimensions, that would make this 16 and this 12 and this 10. Ooh, that's going to be a big shed because he doubled them. He multiplied this times 2 and this times 2 and this times 2. So let's see how much that is. Okay, well, 16 times 12 is 12, carry the 1, is 3, drop a 0, 6, 1, and we've got 192, and then multiply that times 10, and we just add a 0, which equals 1,920 feet cubed. Well, did he double his dimensions? Yes, but did he get 480 cubic feet of storage? No, he didn't. It's way too big. That's like 4 times bigger. So I do not think that that would work. No, because doubling the dimensions would quadruple, which is 4, right? Quadruple the volume. Okay. If he wants to keep the same height, what could the other dimensions be for him to get the volume he wants? Okay, so he wants to keep that 8 feet tall, which seems appropriate because, you know, he's probably close to 6 feet tall, and 8 feet tall gives him enough clearance for his head. Okay, but now he wants that shed to be 480, right? So 480, and we said we wanted to change that into 3 different numbers, and the first one we're going to keep at 8. Well, 8 times 6 would be 48, right? And instead of 5 feet, if we did 10 feet, that would be 4,800, right? So let's do 6 feet here, and then we could double just one wall. If we just double this one wall to 10, now it looks like we would have it. So 8 times 6 times 10 equals 480 feet cubed. If he wants to keep the same height, what could the other dimensions be for him to get the volume he wants? Okay, so height would be 8. Length would equal 6 feet. And width would equal 10 feet. All right, that's actually our answer. You don't have to have that answer. There are other answers. There's more ways to break this apart. Okay? All right, if he uses the dimensions in part B, which we just did, what could the area of the new shed's, what would be the area of the new shed's floor? Just the floor and its area. So what is area? Area equals length times width. With our new dimensions that we just created, that would be 6 times 10, which would be 60 feet, not cubed, but squared. What would the area of the new shed's floor be? 60 feet squared. Okay, all right. Yes, story problems. I love them because they make you think. All right, now breaking some of these numbers apart is a little tricky, so you have to know your math facts. How can you break that down? 3 numbers that multiply times each other to get our end result. Let's see if there's some of that in your homework today too. I bet there is. Sure, yep. Ren wants to put some artwork in 3 shadow boxes. She needs the volume to be 60 cubic inches, but she wants them to be all different shapes, so you have to make shadow boxes with 60 cubic inches. So how are you going to break 60 apart into 3 different numbers multiplied by each other? Okay, so be careful. Finish your exit ticket. I will read it with you right now. A storage shed is a rectangular prism and has dimensions of 6 meters by 5 meters by 12 meters. If John were to double these dimensions, Jean, because it's a she. If it were a boy, it would probably be John, but it's a she, so it's probably Jean, believes she would only double the volume. Only double it. If she were to double these dimensions, she believes she would double the volume. Oh, well, we already know the answer to that because we've already done that before. In fact, we just did it in this problem right here. So go back and look at number 4 if you are confused as how to do that. Your numbers are different. You're still going to have to draw a picture, and you're still going to have to explain, okay? Do a good job. Be very complete sentences, please. Then you can come back and finish that homework. And if you have questions, let me know in class. Have a great day.